Hello everyone, this is Professor DePaulo, and today we're going to run through an independent groups t-test problem step by step. And here's the problem we're going to look at. A researcher wants to know if there is a difference in how busy someone is based on whether that person identifies as an early bird or a night owl. The researcher gathers data from people in each group, coding the data so that higher scores represent higher levels of being busy, and test for a difference between the two at the 0.05 level of significance. So based on this, we're testing a non-directional hypothesis. So if there is a difference, it means non-directional because there's no direction given here. So it's going to be two-tailed test at 0.05. The null is going to be that no difference in busyness. There's no difference in busyness between early birds and night owls. The alternative is that there's a difference in busyness between early birds and night owls. So it's non-directional. Here's the t-value for the independent groups t-tests. Remember, we have different people in each group, of the two groups. So mean 1 minus mean 2 over square root the pooled variance over n1 plus the pooled variance over n2. And to find the pooled variance, we have to find the sum of squares of group 1 plus the sum of squares of group 2 divided by the degrees of freedom of group 1 plus the degrees of freedom of group 2. So we have to work on the sum of squares and we have to work on the means. So let's do that now. We're going to find the mean of the early bird, which is group 1, and the mean of the night owl, which is group 2. So I'm going to go into let me go into R, open up R, which is posit cloud. So R is posit cloud. Oh, I don't want that. I don't need to get started. I need to log in here. So we're looking into posit cloud here. We're looking at these problems, and I'm going to find the sum of the early bird column to begin with. So let's find the sum of early, and that's 214. So the sum of early is 214. Let me move this out of the way. So here we have sum of x1, and we have that to be 214. And then we want sum of x2 here. So let's go back into this and find the sum of night owls. And that's 156. So that's what I did. I added everything up. That gives me the sum. Now I need to find the means. So the mean of group 1 is 214 divided by the number 1, 2, 3, 4, 8. So the mean of group 1 is 214 divided by 8. So I'll just do it this way. 26.75. Not a friendly number. Mean of group 2 is 156 divided by 1, 2, 3, 4, 5, 6, 7, 8. You can have different numbers in each group, different amount of participants. It's okay. For the independent groups t-test, you do not have this need to have the same n. So let's do 156 divided by 8, or the mean of night. 19.5. Not friendly numbers to work with, so that'll give us the numerator here. But to do the variance, now these are not integers, these are not whole numbers, so I don't want to do the deviation score method. I'd rather do the computational method for variance. So if you remember what that is, it's variance equals sum of x squared minus the sum of x quantity squared over n, all over n minus 1. So I want to do that for both of these because it's going to be easier than doing the deviation scores and squaring the deviation scores. But all of this is going to be on the sheet. So all these formulas are on the formula sheet that I'm giving to you. So I'm going to use this computational scoring method. So the first thing I need to do is square each of these values. And to do that, I'm going to do early squared. And those are my values. So I can copy and paste them. So these are the values for early. That's probably not a good idea to do that. So I have to be a little bit more careful what I'm doing here with copying and pasting because it's not wanting to delete it. So these are the values here for the x1 squared. Well, I should say x1 squared values. So this is early squared. And I have 529, 784, 729, 1089, 676, 900, 484, 625. I know that's crooked, but I don't know. Using this tablet, I tend to write more crooked here. And I'm not able to get at this here. Okay, I'm trying to delete this. The junk that I put here, and it's not letting me do it. So I won't do that again. So let's ignore these numbers here for now. I'll just cross them out. Actually, I can erase them probably. Nope, I can't. Sadly, let's see if I can select it. And delete it. Okay, well, I'll leave it there for now. Let's do x2 squared. Just trying to make my life a little easier so I don't have to go back and forth. So this is the night owl. That's probably not the best idea. I can do some of these in my head. 361, 676. What else I got here? 324, 144. And the last value is 625. So we need to find the sum of x squared 1 and x squared 2. And this is going to be the sum of x squared 2. Sorry, it's a little bit cramped. This is what happens when I do the problems on the tablet. Sometimes it's a little hard to write on the tablet. I mean, I'm used to it, but it's not great. It's not a great experience. So if I sum up early squared, I get 5816 here. And if I sum up night squared, I get 3306. So those are my two squared, x1 and x2 squared. Now I'm going to put it into the formula here, down here, that you see. So let's not let me move this. That's why. Sorry. Let me move the screen down here a little bit. Make some more room. Okay, so sum of squares 1 for group 1 is going to be sum of x squared, which is 5816, minus sum of x, which is 214, squared, over 1, 2, 3, 4, 5, 6, 7, 8. So sum of squares of 1 is going to be 5816 minus 214 squared over 8. Let's do that here. That gives me 5724.5. 57, it's not a good 7. Let's get rid of that one. 5724.5. Sum of squares of 1 is going to be that. So 5816 minus 5724.5, 91.5. That sum of squares 1, so we want that. And then sum of squares 2 is going to be 3306 minus 156 squared over 8 again. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 3306 minus 156 squared over 8. $3,042. So that comes out a little bit better. It's going to be 3306 minus 3042. $264. $264. So those are my two sum of squares. So to find the pooled variance, I get 91.5 plus 264 all over degrees of freedom 1. So the degrees of freedom here are n minus 1. So degrees of freedom 1 is 8 minus 1 is 7, right? Degrees of freedom 2 is 8 minus 1 is 7 again. So they're both 7. So this is going to be 7 plus 7. The pooled variance, 91.5 plus 264. $355.5. All over 14. 55.5 over 14. 355.5. 25.39 rounded. That we need 2. So now going back to this t-test here. Sorry. Making more space for myself here. We get t is equal to mean 1, 26.75, minus mean 2, 19.5. Those are from the beginning of the problem, right? Divided by square root s squared sub p 25.39 over n1, number in group 1 is 8, plus 25.39 over, that's 39, sorry, over n2, which is also 8. So 2675 minus 19.5, 7.25. So this numerator is 7.25. Now the denominator is going to be 25 plus 25. It's going to be 50.78 over 8. Whoops, sorry about that. I'll click some button here. Let's put that 50.78 over 8. So let's do that. Let's just resize this. So we got 25.39 over 8 plus 25.39 divided by 8. Let's do it separately. So 3.17, right. Right, so 6.35 on the bottom. And we want the square root of that, 6.35. So 7.25 on top. Square root of 6.35 on the bottom. Is 2.52 rounded. So you're going to have a little bit of rounding error here. It's not a big deal. 7.25 divided by 2.52. 2.88 rounded is my t value. Now I need my crit t. So for my crit t, I need to go into the the table. So let me go find the table here. So I've put the table into format here on Brightspace. So here's the formula sheet uploaded on Brightspace under the study guides. And then here's the table. So my degrees of freedom here are n1 plus n2 minus 2. Right? n1 plus n2 minus 2. So I have 8 is 16, minus 2 is 14. I have 14 degrees of freedom. I want 0.05 two-tailed. And 14 degrees of freedom. And it looks like I have 0.05 two-tailed is in the second row here. So 0.05 go down to 14. And it looks like it's going to be 2.145. Plus and minus. So plus and minus 2.145. Right? That looks right. Check it again. 2.145. I can also check it in R. I have 14. No, that's 0.05. I want 0.025. It's giving me something different. I don't know why that's giving me something different. I put something in wrong here. P lower tail is true. Or is it? Okay. I'll check it afterwards. It's not working for some reason. Let's go back to the problem. We know that it's plus and minus because it's two-tailed, so it's both plus or minus. If you want to draw the little curve, you can draw a little curve here. There's 0. All the way out here is 2.145, right? All the way out in this tail is negative 145. And 2.88 is somewhere over here. So it's in the tail. It's more extreme than the critical value. So we're going to reject the null. And we're going to say that there is a difference between early birds and night birds in terms of busyness. It looks like the early birds are more busy based on the mean being higher here. The mean here is 26. The mean for the late night owls is 19. So maybe the early birds are more busy. We rejected the null here. And that's basically our conclusion at the P of 0.05 two-tailed level of significance. And so early, night. And when we run the t-test in R, we get 2.8775, 2.88, and that's our value here, 2.88. So we're within rounding error of the exact t-value in R, but that's the exact t-value in R is 2.8775. And I could put variance equals true. So I could just set the variance to be the same. Right, and that just changes the p-value a little bit. So it's significant. So the p-value here is degrees of freedom of 14, p-value is 0.01. So the actual p-value is 0.01217. That's much less than 0.05. So we use the critical value to reject the null, but we can see that it's really, really significant. Close to the 0.01 level. So we can be pretty sure that there's a difference between early birds and night owls in busyness. And that's it. So hopefully that helps you. If you have any questions, let me know. I'll be back for more videos doing the problems here shortly. So bye for now.